Hello again, my students. Just continuing on. If you remember the other day, we kind of went through mutation, talked about what causes mutations, that sort of thing. And that leads us naturally, kind of going back a little bit into reproduction and development when we were talking about that, to different kinds of what's called selective breeding. Now, selective breeding has given us a lot of things through the years. Okay, and there are a few different kinds, and one of which, right here, you know what it is, kind of gets picked on. We'll explain that. Okay, the first is artificial selection. And the nice part about all of these is, although some of them are funny and you might have jokes about them, they are all essential for most of the food you eat. So let's go through these real quick. Artificial selection. Choose the best features, the ones that you want, and breed them into the species by breeding it with another one that gives you the feature that you want. Okay, so if you want very tall corn or very long ears of corn with a lot of seeds, you're not going to take the little tiny seed and breed it with the large seed. You want to breed the best with the best. It's used extensively in dog breeding as well. The problem is a lot of people brag about their purebred dogs, but purebred dogs often have a condition known as hip dysplasia, which means their hips don't really stay in the socket well, and it can basically make them so they cannot walk. Cat deafness. If you breed pure to pure to pure to pure, and you try and make it a perfect pure individual, for lack of better terms, unfortunately, sometimes you breed the recessive back in as well, and that's when you have problems. Inbreeding. This is breeding good genes to good genes once again, even if it's a brother to sister, mother to son, father to daughter, cousin to cousin, something like that. For the most part, this can tend to be recessive, and it's one of the reasons we have laws about who you can marry and have children with. And I know we shared the story a while back about the couple in England a few years back that petitioned the parliament and got the right to marry each other as a brother and sister and have children. If you do that too much, you're going to start running into that recessive cropping up again. And human recessive genes, when they start cropping up, can be a bad thing. Hybridization. Okay, right here. Breeding a homozygous dominant, let's say big B, to a homozygous recessive little b, and getting all heterozygotes. Okay? It doesn't take a rocket science to figure out if you had a Punnett square that went big B, and little b. Everything in there would be big B, little b. The heteros are then bred together, and you throw away anything that's recessive, but you keep the dominants and the heteros. That's hybridization. Best example is Santa Gertrudis cattle. English Shorthorn cattle have fantastic quality beef, but they're used to a somewhat cooler climate and they don't grow all that quickly. Brahman cattle will grow in very, very warm climates, and they will grow very, very quickly, but their beef isn't all that great. So if you take good beef and you breed it to a heat-resistant beef, you're going to have good beef that is heat-resistant in general, not always. Some are preserved by vegetative propagation. Remember, we talked about what grafting is. Remember the tree at Syracuse University, the tree of 50 fruits. That is a way that we can take different mutations and put them together and ultimately end up with a better quality of fruit. Seedless oranges. Where do you get the seeds to plant a seedless orange tree? You don't, because they don't have any seeds. So that's one of the things you have to think about. Same thing holds true with those cotton candy grapes that we know and love. Oh my gracious, they're good. Okay. Apples. Apples are really, regardless of what kind of apple you get, basically all apples are pretty much the same. And you are enjoying, let's say you get a Cortland apple or something like that, you're enjoying a mutation that tastes good in many cases. Last is something called recombinant DNA or genetic engineering, and this is going to be very, very difficult to teach long distance. So I'll probably put up a few little videos. Could be very important. That's all I'm going to say. It's modifying the actual DNA, and you make very, very tiny, slight mutations And the organism, over time, generation after generation after generation, has better traits for our needs. The biggest one that I can think of is human insulin. It used to be produced only by using pork pancreas or pig pancreas. I can't even venture a guess when we finally took the human DNA, transferred it into mice, and they ended up producing human insulin. Okay, that was a pretty neat thing. And the cat says hi from his perch over there. Changes in chromosome structure. I've made this as easy as I could using loaves of bread again. If we're going to change a chromosome around and we're going to move a gene or a chunk of DNA essentially from one place in the chromosome to another place, very often these mutations can be fatal. It's like taking a slice of bread from the middle of the loaf and moving it to the end. Okay, you leave a gap. You leave the piece at the end. It's not a good thing for humans, especially. Addition is adding genes. Okay, can be fatal, but it's often used in agriculture. So pretend you have a loaf of wheat bread, and then all of a sudden you slip a slice of white bread into the middle. Why would you want to do this? It's happening a lot with tomatoes right now. They've added genes to them so that when they freeze or something like that, they come back and they're fine. They have tomatoes that are, I can't remember the name of them, I think they're Everlast tomatoes that you may find on the shelves, and they can last for months on the shelves, and they'll still stay that bright red color and not start to rot and have mold on them. Deletion is removing a defective or unwanted gene. This one is going to really take off in medicine. The possibility is there if a gene or a feature is present in a person that we could essentially hit them with what's been termed a gene gun and knock that bad DNA out. And then inversion is flipping part of a chromosome so that the sequences are slightly different but still preserved. You split a loaf of bread in the midpoint, turn it around so now that the crusts are in the middle. Okay, no one eats the crust anyway, right? So that is an example of inversion. So this is really leaning a lot to healthcare, especially with what's going on right now. Pretty interesting stuff that could possibly happen down the line. Tomorrow I'll go through and do some DNA history and structure with you, and then the day after that I'm hoping to get something together for protein synthesis. So go wash your hands. Hope to see you soon. Bye-bye.